Alright, in this statics problem we're given a hook problem. And it looks like a hook has 3 cables attached to it as illustrated, where alpha is 35 degrees. The resultant magnitude and resultant direction of the 3 forces is most close to. Okay, so that's the problem we have to find. It looks like we have most of the information here. Alpha is 35 degrees. And then we have our 30 degrees here. Looks like we don't have to solve for any forces. They're given to us. So let's go ahead and get started. We'll go ahead and start out by drawing our free body diagram. We'll draw our forces out here. Our 200 newtons, our 150 newtons, and our 100 newtons. We'll establish a coordinate system. It looks like blue is going to be our X coordinate system. Y is going to be our red coordinate system. And then if you look right here, these create our right triangles. Alpha is here. So if you want to break this into the X component, all you do is you take 200 times the cosine. Cosine breaks it into the X component of 200 newtons times the cosine of alpha. If you want it in the Y component, 200 times the sine of alpha. And this is going to be alpha plus 30, because remember this one is alpha as well, and then it's going to be additional 30 degrees, so we'll just go ahead and add 30 there. And then this one here is alpha. So we'll go ahead and sum our forces in the X direction. We'll make this our datum, so everything to the left is going to be negative. Everything to the right is going to be positive. That's where we get the negative 200 newtons times cosine alpha, plus, because we're going to the right, 150 newtons times the cosine of 30 degrees plus alpha, plus 100 times the cosine of alpha. We'll go ahead and break everything into the Y components. Everything below the blue line is going to be negative, so all of our equations are going to be negative, and then we multiply those times sine of the angle to get it into the Y component, which is this right here. And then we are required to find the magnitude. The magnitude is simply the sum of the squares, and then you find the direction by taking the inverse tangent of y over x, and then that's our answer for our x and our y. And then it looks like here's our magnitude. Let's go ahead and see what that looks like graphically. It's good to understand how to do it mathematically, but graphically you're going to be required to explain which direction the actual vector is headed. So we'll go ahead and break this up. So this is equivalent to, okay, so there's our X and Y components, and there's our magnitude. So let's go ahead and draw it out here. That's our X, and then this one is going to be our Y, and then we have to give it a direction and magnitude. That there's going to be our magnitude, and then we'll go ahead and give it our direction, and that's your answer. If you like this video, don't forget to like and subscribe. Thank you for watching.